Okay, so we're going to start out here at the same spot that we were in the last video at the very end. So we have the satellite model and our V2 model. And so what we'd like to do is add a payload system to this satellite system. And we'll start with an infrared camera. We'll build that starting with the geometry module. So we'll add that to the system. We'll call it Geo. And then the only thing this does is basically sizes based on the aperture area of the infrared camera. It sizes the infrared as a percentage of the aperture area. And now let's add the infrared camera itself. We'll start with the low fidelity version of it. It's called FLIR. That stands for forward looking infrared, even though it's not. It's just really a generic infrared camera. This was named in a previous project. So we'll add that to the system. We'll call it FLIR, and then we'll add another subsystem downstream of the infrared camera called a GCS, which basically just consumes the outputs from the FLIR model. We'll call that one GCS. So let me just explain this a little bit. So like I said, the geometry subsystem basically sizes in terms of the percentage of aperture area, sizes the infrared camera. The infrared camera computes signal-to-noise ratio, cost, weight, and power, which is consumed by this GCS subsystem, which also calculates the accuracy of the camera using this function. So as the signal-to-noise ratio increases, the accuracy of the camera becomes better and better, up to 100%. So, and we're stipulating here that the camera is used for something like, monitoring populations of animal species that are going extinct, for example. So we want an accurate count every time the satellite passes over the zone of interest. So that's what this accuracy is about. And we just made this equation up. It just seemed like a good qualitative relationship to use. So that's what that's all about. So it's really a pretty simple model. This is the low fidelity version of the model. So what it really consists of, there's a high fidelity version of the model which actually uses a range equation and a function of many input parameters, geometry, orbit conditions, and so forth. But this simple equation, this low fidelity version, is just a function of the size factor itself, and it's actually, in this case, a linear function of that. So the signal-to-noise ratio, cost, weight, and power are linear functions of the size factor. So that's our low fidelity model for the infrared camera. We've built it. Let's take away, while we're at it, the satellite model and the V2 model, just to get it out of the way. So we'll do a delete sat here, and we'll do a delete V2. And so now we have just the payload model of interest. And at this point, what we can do is set the architecture. Okay, so we want to set it to be something descriptive. We'll call it FLIR. And then we want to add a level. We'll call it low. So now we have the FLIR low architecture and fidelity level. And now what we'd like to do is go through the steps needed to turn that into a medium fidelity level model. So what we're going to do is delete one of the subsystems. To do that, we'll delete the FLIR subsystem, and we'll just add the FLIR mid subsystem, and we'll call it FLIR as well. So it doesn't look like anything different, but these equations are a little different. This is basically a better curve fit based on the size factor. And you can see that the fidelity is different by this 2 under fidelity level. So the low fidelity model was fidelity level 1, this one's 2, the highest fidelity is level 3. Okay, so we've changed the fidelity level, and what we'd like to do now is add a new level. We'll call it mid, for example. So we have the 2 fidelity levels of interest. And at this point, what we can do is introspect the history a little bit, just to remind ourselves of what the steps were from getting from the low fidelity model to the high fidelity model. And basically, here's when we added the low fidelity level, and here's where we added the mid fidelity level. And the 2 steps in between, it's very simple to get from one level to the other in this case. This is just sort of contrived that way. But it was steps 127 and 128. So we added a fidelity level, and we deleted a subsystem and added subsystem from the library. So it's 128 and 129. So what we're going to do is name that history. We're going to say fleur low to fleur mid, and 128 and 129 are the steps we want for that. We're going to say OK. If we show the history now, we can confirm that in fact we have fleur low to fleur mid steps here, and we're ready to use that. So we can also create a fidelity action based on these steps. We can say add action, fleur low to fleur mid, and now we have basically the ability to go from the low to the mid using the fidelity action concept. So just to show you that, we're at the mid level, so we'll run that action, and we'll see that that's fidelity level 1 now. If I'm at the low level, I'm at the low level now. If I run this in the forward direction, I'll run the action. I'm at fidelity level 2. And now we can build this whole chain of levels and architectures. And we're going to see that in the next video. I'll show you a pre-built payload model with all the fidelity levels and architectures, all 9 of them basically.